Hello, it's Aida Zahwa and it's the review of MIPS Part 2. So the first one in is instruction format. The machine language. The machine language. Computer don't understand ADD or A or 17 or 18. So instructions are translated to machine language. For example, the number at above translated to 00000010 and so on. Translated to a computer language, to machine language, and it has instruction field like opcode, RS, RTT, RD, shant, and found. So the first question is, which file in the MIPS instruction format specifies the operation to be performed? The answer is opcode. Explanation: the code fields in the MIPS instruction format specifies the operation to be performed, such as ADD, subtract, or load. Next, immediate instruction. So the first one, constant. It uses all over code. MIPS does something in between. Instructions have only 32 bits, needs some for opcode and register. And then MIPS instruction format. It has three instruction format. The first one is true register, no immediate. The first one is R. It has true register, no immediate. It for arithmetics and logic. The second one is I. It has true register, 16-bit immediate. The function is for load or store, branch, and immediate. The last one is J. It has a register, 26-bit immediate. The function is for jump. Okay, the question is, which MIPS instruction format is used to branch instruction? The answer is I format. Explanation: the I format it is used for branch instruction in MIPS. It includes fields for the opcode, source register, destinational register, and immediate value. Okay, next, addresses in branches and jump. Branch instruction, BNE or BEQ, I format, 16-bit immediate. J format has 26-bit immediate. How to handle branch in 32 bits addresses? So the first one is treat BNE or BEQ as relative offset, ADD to current PC, and treat J as an absolute value. Replace 26-bit of the PC. Okay, the question is, what is the MIPS assembly language instruction used to be performed an unconditional jump to a target address? The answer is J. Explanation: the J instruction in MIPS assembly language is used to perform an unconditional jump to a target address specified in the instruction. Next, large constant. Loading larger values. So the first example is load upper immediate or LUI. It loads upper than 16 bits. And the second one is immediate or ORI. It loads lower 16 bits. For example, this language machine. So in LI and in LUI R2, it changed like this. So put the zero at the back. And for OR R2, ORI R2, put the front language machine to the back. So the question is, in MIPS, how many bits are used to represent the immediate value in LUI instruction? The answer is 16 bits. Explanation: in MIPS, the immediate value in the LUI or load upper immediate instruction is represented using 16 bits. The next one in instruction formats immediate summary. So instructions have different encodings to store different types of data. MIPS has three types for different uses. R is for arithmetics and logics, I for load or store, branch and immediate, and J for jump. Encodings limit encodings limit how much data we can have. Trade-off in design. Op- Trade-off in design optimize for common case and support general case. So the question is, in MIPS, which instruction format is used for instruction that operate on an immediate value? The answer is I format. Example, explanation. The A format or immediate format in MIPS is used for instruction that operate on an immediate value such as ADDI, ORI, and all LW. And next is procedures and job. Okay, so procedures are important for structure programming. So avoid the repeated data and call function you didn't write. What needs to happen is put the data where the procedure can access it, start the procedure, and return to the right place in caller. So the caller calls the procedure is the callee gives callee arguments, the callee return the result or data to the caller. So the question is, what is the purpose of a stack in MIPS procedure? The answer is to store local variable and temporary data. Explanation: the stack in MIPS procedure is used to store local variable and temporary data. It provides a space for storing and managing data specific to a procedure's execution. Next, saving and restoring register to the stack. Saving and restoring data. In here, we need a register convention so callers and callees know what to expect data. Saving is copy a register to memory where they won't be overwritten. And restoring is copy a register from a register back from memory to the original register. Saving register on the stack. So MIPS has a special part of memory called the stack for saving register. The stack pointer kept in SSP or R29 keeps the address of the end of the stack. And in MIPS, the stack grows down. So the question is, what is the purpose of the stack pointer as the register in MIPS? The answer is to point to the top of the stack. Explanation: the stack pointer register in MIPS is used to point to the top of the stack. It keeps track to the current position in the stack and is updated when values are pushed or popped. Okay, so this is the example of procedural calls saving register. You can look at the screen. And then it's the second example of procedure calls in saving register. So the question number one is which register is commonly used as step pointer in MIPS? The answer is SP or the step pointer. Explanation: the step pointer register in IPS is commonly used to point to the top of the stack. It keeps track of the current position in the stack, and it often used for saving and restoring register during procedural calls. The second question is, which register is commonly used to pass argument to a subroutine in MIPS? The answer is argument register. Explanation: the argument register is commonly used to pass argument to a subroutine in MIPS. Additional arguments register can also be used depending on the number of arguments. So it's the procedure call summary. MIPS register name and confession. The average result is for data from the procedure. Argument is data for the procedure. Caller save is the caller used this register, then the caller must save them in case the caller writes them. Callie save is if the callee used this register, then the callee must save and restore them in case the caller used them. The question: what is the MIPS assembly language instruction used to call the subroutine? The answer is jump. Explanation: the jaw or jump and link instruction in MIPS assembly language is used to call a subroutine. It transfers controls to the specific subroutine and save the return address in the RA register. And the last one, other AIS. The example of other AIS, such as X68, X86, like Intel or AMD, ARM, like Samsung or Apple, JFM or Java, etc. Basic machine types. The first one is memory to memory machine. Instruction can manipulate memory, but it needs to store temporary values in memory, and memory is slow and big. The second one is register machine. It holds temporary variables in a register file. Register file is smaller, for faster than memory, faster programs. And then fewer address and code. It calls the smaller programs. So the first question is, which ISA is commonly used in mobile devices and embedded systems? The answer is ARM. Explanation: ARM is commonly used in mobile devices and embedded systems due to its low power consumption and efficiency. The second question is, which ISA is known for the variable length instruction encoding? The answer is x86. Explanation: x86 ISA is known for its variable length instruction encoding, where its instruction can vary length from 1 to several bytes. Okay, it's the end of the explanation. Thank you.